The title of these talks is Night Reveals a Universe. Let me share the screen and start the talk with the images. And that has another sentence. Night hides the world, but reveals the universe. And most people are more familiar with the first part, that night is an eerie environment, rather unsafe to us to explore, to be outside. And that comes from our ancestors. Through thousands of years, human being has never been a night animal, never been a nocturnal species. So therefore, we are not really comfortable sometimes with the darkness. And what my images, my colleagues in the World at Night program is trying to break the barrier is that night has plenty to offer to explore through especially eyes of photographers, because then they can share this beauty with other people. It's not necessarily about astronomy. It has a big part of it, of course, is astrophotography, but in a broader context, night escape photography could be revealing nature at night, could be revealing an architecture inside a city with some stars above it. Sometimes we go more towards astrophotography and aim for a constellation, celestial conjunction, an eclipse, Aurora Borealis, or Zodiacal Light, which I will talk about it in this webinar. But it's not limited to astronomy. So it's going to reveal whatever is available at nighttime on this planet. And it begins right after sunset. This is, for example, about 15 minutes after sunset. Sky is still pretty bright, so I was using an ND lens on a wide angle, ND filter on a wide angle lens from the top of La Palma, Canary Islands. That's a paradise island I visit every year for my masterclass. It's called AstroMaster. So I'm here with a group of students next to me, and we are just thrilled by this beauty of moving clouds. So using ND filter, I stop down the exposure to about 20 seconds to get this fluid motion of the clouds. And that's the beginning of a night session. Some minutes later, the first stars will appear above the sky. But let's go to somewhere else. Again, very close to the sunrise, sunset. This particular one is near sunrise in the morning. But you see the same phenomena after sunset as well. It's called the Earth shadow. First, on the foreground, these are ice structures, the formations, which are typical in high altitude parts of the Andes. This one is in Chile, and you see the same phenomena in Bolivia and some other countries at about 5,000 meters or higher. But what you see in the sky, that blue band, is the shadow of our own atmosphere, our own planet casting over the atmosphere. Most people don't realize it because the horizon could be obscured by something, for example, trees or a city skyline, or could be not transparent enough. So if you are in a very clear condition, especially in high altitude where transparency is pretty high, then look for the Earth shadow right after sunset in the opposite direction. So look to the east when the sun is setting, 5 minutes, 10 minutes after the sunset, it's very evident. And look to the west if the sun is rising just 5-10 minutes before that. So there are many atmospheric phenomena, which is part of night escape photography. Let's go on. And same place, now we are at midnight, the moon is up, and everything is illuminated with the moonlight here. And that's perhaps the most uniform way of illumination you can achieve when the foreground is huge. For example, a mountain or such a large formation, you cannot light painting it with an LED or any other source and become very uniform and natural looking like this. So use the moon as much as possible. But what phase of the moon is the best for a night escape photographer? If you use the full moon, the sky would be almost vanished. Only a few stars will be visible in the sky. The Milky Way is gone. The constellations are not very much identifiable. And if you use the crescent moon, the illumination is very little. The foreground would be dark, and of course the sky would be very starry if you're in a darker sky location. But somewhere between the phase of between 20 or 30% of illumination to 50% is the ideal moon phase with a high ISO performing camera. At 50%, you're looking at the result right now. This was the first quarter moon, and that means 50% illumination. Half of the moon disk is illuminated from our point of view. And if it's less, like 30% or 20%, you still get good illumination if the foreground has a very high albedo. That means a high amount of reflection, for example, snow. Then even with a lower phase of the moon, you can reveal the foreground. Or sometimes you don't need the moon. You capture the foreground as a silhouette with the background, the sky. And we will go through all these sources of illumination at night one by one, especially looking at this image, which has 3-4 different sources of illumination. It's a very memorable image for me because back in 2007, I decided to shift completely from analog to digital, and this was the reason. Before that, I was trying various digital camera, and the result at night in long exposure was always too noisy and really disappointing. So I was keep shooting with film. But then this camera came from Canon, and using a fast lens, I realized it is about the time to change my astrophotography to digital cameras. With a 20-second exposure, we can reveal so many stars, and the noise is controllable. It's not too bad. The image is showing the Alborz Mountains of Iran, which is north of Tehran, the capital. The light pollution of Tehran is partially visible on the lower right. So that glow is coming from a city about 70 miles away. Then there is another glow, the red part, which is the Haraz Valley connecting Tehran to the Caspian Sea. These are cars driving by. It almost looks like running lava from a volcano, but the red is coming from a road. And from above, we have the moon illuminating the mountains and showing, giving us this tint of blue in the background sky. So whenever the sky is blue, naturally, not because of changing the white balance in the camera, it is due to moonlight or twilight. Otherwise, we don't have this natural blue in the sky. Constellations Orion and bright star Sirius, the icons of the winter sky in the northern hemisphere, are visible in the image. Now, let's go through what we have as the sources of light for a night escape photographer. Twilight, it's commonly used, moon, or artificial light. So you have two of these in this image. Then comes starlight and the Milky Way. That means if it's truly dark, you can use the Milky Way as a source of illumination, a very high ISO and long exposure, 20, 30 seconds. You can see illumination from the central part of the galaxy. It's bright enough, especially in the southern hemisphere, where the galactic core rises very high, or the tropics. Zodiacal light, I will explain that a little bit later. This is very mysterious and amazing phenomena to see in the sky. Unfortunately, I would say more than 90% of the planet cannot see it due to the light pollution, because it needs truly darker skies. It could be also aurora. In polar latitudes, aurora can illuminate not only the sky, also the foreground in your image, and very faint, colorless phenomena called air glow. It's colorless to the eye, but the camera will pick the color, and it's either green or yellow-red. And it's sometimes confusing to beginner night escape photographers. They don't know if they have captured aurora from their latitude, which could be very surprising. For example, from near Sierra Nevada in California, you don't expect to see aurora frequently unless it's really a huge activity. But it could be easily air glow, because that has the same color, but could be identifiable if you get experience a little bit in this. And I will show you a few examples later on. So night escape photography is really the art of handling all these ambient lights. From technical point of view, It's not that challenging. There are just few numbers. The most important parts to learn is how to handle these lights and how to plan to be at the right time in the right location. In order to plan, I will introduce you a few apps, but most important is just to learn a bit about night sky and practical astronomy or stargazing. Using a book or two and some online information, it's not only fun to learn about the stars and constellations, how the Milky Way is rising and setting, which season is right, but it's also very educational, and it dramatically increases your interest to the night sky by knowing which star you're capturing. It's the same for any other field of photography. If you're a wildlife photographer and you know a lot about animals, you can communicate with your target, with the subject, much more than somebody who has no idea about the animals. And you know which one is on danger of extinction, which one is coming out at night. And these are the same knowledge that we need to know about the night sky in order to be a successful night sky photographer. Now let's have a little tour around the world, starting in Nepal. An image from 2009. I was on a hiking trip for the World at Night project with my colleague Oshin Zakarian, and after going through a lot of mist and fog and almost hopeless, we finally got above the layer near the famous town, the village of Namche Bazar. The view includes Everest on the left, Lutsi, and then Amadaplam on the right side. In the sky, you have the blue coming from the moonlight, which is also illuminating the mountains in this image. But the albedo of the valley is very low. It's pretty dark. That's why it's not reflecting much, and it's not showing much detail in the shadows. Now we are in the Canary Islands. Again, the moonlight, this is the first quarter moon, 50% illumination, shining on everything, the ocean, another neighboring island, and brightest star, Sirius, and the second brightest star in the night sky is Canopus, which is a southern star. So from the northern hemisphere, for example, from latitude of Central California, it's very close to the horizon. As you go closer to the tropics, it's rises higher and it becomes a prominent star. But Sirius is very much visible most of the winter nights. Same place in Canary Islands, La Palma, and look forward to be here hopefully in October if we don't get problems again with our workshop and the COVID restrictions. This is a place to a large observatory on top of a volcanic caldera. I would say it's one of the most photogenic observatories on the planet. The astronomical twilight is ending. That's why sky is becoming very dark. We have several phases of twilight. And the last one, which ends, is astronomical twilight when the sun is between 12 to 18 degrees below the horizon. So at the moment, you're looking at the image when the sun was about 15 degrees below the horizon. So now the Milky Way is completely visible, but the sky is not completely dark yet. You still have this color of twilight. And I intentionally planned for that. As I said, nightscape photography is really the art of handling all these lights. 10 minutes later, this nice color on the high cirrus clouds were gone. The orange on the horizon was gone. Of course, the Milky Way was there prominently, but the combination of the colors is only there for a few minutes. So you have to plan and you have to be there on the right time. The light coming from below the caldera is from a town, and it's illuminating the clouds from underneath. These are typical exposures. I will give you a series of information on another slide later on, and most of the images I'm showing you are following those golden numbers of nightscape photography. Now we are shooting with a telephoto lens. This is the Sigma 105 millimeter. It's a pretty fast lens, very impressive lens at 1.4. It's very sharp and it's rather heavy. And I was pointing towards two planets. Venus is the brightest point. Venus is actually the brightest planet in the Earth sky because it's not only very close to the Earth, it also has a very high albedo. It's almost like a mirror because it's covered with clouds and reflecting the sunlight very much. These nights you can have a look at the Venus over the western horizon after sunset. About 40 minutes to 1 hour after sunset, look over the west and you will be surprised by this very bright object, which is coming gradually higher in the evening sky. So by August and September, it becomes really prominent object in the evening sky. And some people might be too surprised and report it as UFO. Venus has been always on the list of UFO reports because people are not expecting to see such a bright star in the sky. It's not moving like planes. It will be there for a while. The second one in the image is Jupiter. Jupiter is also pretty bright, but having them both together, it's called a conjunction, celestial conjunction. It becomes a phenomena that makes your image very unique because I usually mention that photography is based on 4 elements. Art, technique is very obvious. Then comes a story and the moment. So if you bring all these 4 together, the photo has more impact to the audience. And the moment here is a conjunction of 2 planets that might not repeat for several years, especially with the third object in the background, which is that cloud, the little pale purple cloud is the Lagoon Nebula, some 5,000 light years away in the galaxy. And the clouds in the foreground are the tropical towering cumulus clouds, typical in the tropics. I captured this from Guatemala in Lake Atitlan. Now we are in Chile, very famous country for stargazing and astrophotography because it has the Atacama Desert, one of the darkest places on the planet, one of the driest as well, and because in some areas it has more than 300 nights of clear sky, there are many observatories there. It also has a very good transparency and a steady light coming from the stars. That's very important. It's called the astronomical seeing. So astronomers can really penetrate to details of the far universe using the large telescopes from high altitude areas of the Atacama Desert. This is one of those sites, one of the observatories, and it's in the morning just before sunrise and before twilight is becoming too bright. You see the red is starting. That's the beginning of twilight. So the beginning of astronomical twilight, but there is the Milky Way is obvious. That bright object is Venus, but there is this cone shape glow, which is almost colorless, a little bit pale blue, completely colorless to the eyes, however. And that's called Zodiacal Light. Zodiacal Light is best visible from the tropics. From other latitudes, such as mid-latitudes where we are located, many of us, it's best visible in March, April, after sunset, after dusk. And in September, October, just before dawn in the morning. That's when this cone shape is more vertical above the horizon from mid-latitudes and higher latitudes. But if you're in tropics, you can see it almost every night. When the moon is gone, moon is not affecting the sky and light pollution is not there. If you have light pollution, this glow is quickly gone. And it's related to dust in the solar system. It's not in our atmosphere. It's something in the outer space reflecting sunlight, especially from the orbits between Mars and Jupiter, where the asteroid belt is located. Astronomers relates this also to dust coming from Mars itself and some other related to impacts between the asteroids. Whatever it is, it creates a very beautiful element in night escape photos when you are in a dark sky location. And now we're looking at another of those sources of light in a very unusual night. This was perhaps the most intense appearance of air glow I have ever photographed in my entire career, which is now almost 30 years. When I started, I was 12, 13 years as a teenager, as a beginner amateur astronomer. Some years later, I became a professional photographer. And over these years, I've never seen such a bright air glow in the sky. Again, it was colorless to the eyes, but not to the camera. The reason we cannot see diffuse objects with color is that our eyes are almost color blinded at low light. You can try it in your own room. Just turn off the light and you will see all the colors are gone. The only things that are visible in color is when the light is intense and concentrated. If the light of the Milky Way is not that faint, the Milky Way is pretty bright, but since it's very diffuse and scattered, it doesn't activate the cone cells in our retina. Therefore, we don't see the color of the Milky Way, but the camera can capture that. And that's the confusing reason for many photographers who change the color of the Milky Way to whatever they liked, blue, purple, red. Milky Way has a physical color. If you follow with the normal daytime white balance temperature of 5,000, you capture the natural looking Milky Way. If you try it with film, you see that Milky Way has a true single color. It changes through the band of the Milky Way depending on which part of the galaxy you're looking at. Just slightly changes. But where most of the photographers are taking picture, the galactic center, it's pale yellow. And we will come back to that later on in the webinar. Now, about the air glow, these are the combination of colors of air glow. I was at Grand Teton National Park in Wyoming on this night of July 2013. And first, I was very disappointed because air glow, it could be very annoying. It completely covers whatever is visible beyond that. For example, if it's Milky Way over there, Milky Way becomes very diffuse behind the air glow. Air glow is the natural emission of the Earth's atmosphere from about 60 to 70 miles, almost the edge of space. So these are the last layers of illumination from our own atmosphere. And it's related to solar activity, similar to Aurora, but in a different way. So it's not completely direct. For example, when there is a solar eruption, you expect to see bright aurora in the right latitude within 2 or 3 days, if it's towards the Earth. But with the air glow, it could be some days later. It could be not directly related, but definitely the solar radiation increases the air glow. And this is a night without any air glow. That happens too. Air glow is also local. If you see it in one place, you may not see it from another country. So it varies because it's within our own atmosphere. We are in Cerro Paranal, so-called paradise for astronomers, an observatory in the Atacama Desert. And this is a typical view of the Milky Way through a camera and a fast lens, of course. But with the eyes, this view would be completely colorless. You still see colors of the brightest stars in this image. Now, the previous one was example of a foreground which is illuminated only by starlight and a bit of using the silhouette method. But this one is light painted. There was no moon. There was no major sources of artificial light, for example, a village or a town, any kind of light pollution that can contribute to that. So I used a portable LED panel with a dimmer, so I can adjust how much light I'm going to do that. Note that in many of the national parks nowadays, this is not permitted anymore because some photographers use really massively bright light at nighttime in workshops, in light painting workshops, and that can harm not only other people in the park. When they look at these lights at nighttime, it could be unsafe. You're walking on a hike at night and you lose the option of dark adoption, night vision. when there's such a bright light into your eyes, and also very annoying to the animals. That's why using very bright lights at wildlife areas is not permitted in many of the national parks now, those which are registered under International Dark Sky Park. Anyhow, use a gentle light, especially if the foreground is not large. This is a rather a small foreground, so I could light painting it with a very low dim light through 20 seconds of exposure, and I move the light so I don't get very strong shadows in some of the areas. And of course, you know that the light should be from an angle mainly in order to give you a bit contrast, so not exactly from the direct position. In the sky, we have the Milky Way and brightest star Antares, which is the heart of a scorpion, constellation Scorpion. This one is somewhere in southern Australia in Victoria, and there is no moon, there is no light painting, of course, because this is a pretty large foreground, and I just use the natural light. The question is this a blend of exposure? I do not practice exposure blending or any other of kinds of composite that blend different exposures. I like to do single exposure photography. I'm not against that. That's another approach. I like to challenge myself with getting the same result through single exposure photography. And that needs a fast lens, sometimes needs a star tracker at half a speed, which I will explain later on, and needs a pretty dark location. And these are available nowadays. It's a panorama, so it's 6 shots at 15 seconds at f2. So I'm using pretty fast lenses in order to achieve that. And when you are at high ISO, such a fast lens, and 15-second exposure, you can reveal shadows in such a dark place. And even in such a dark place, there is still glow coming from the sky, the air glow, and some little light pollution here and there on the horizon, and the Milky Way itself. Now, another source of light pollution, going through the list that we talked about, is the aurora. It can easily dominate the whole sky in the polar latitudes. This was during one of my annual Iceland photo workshops, and our group next to me was really stunned by these rays all of a sudden coming from nowhere, because it was a low activity night. And the sky was pitch black, but all of a sudden these rays started to dance, and while the rest of the sky was still pitch black, one part of it was completely dominated by rays, which were not as colorful to the eyes, but you can see the color of aurora when they're active and bright. However, camera usually reveal much more than what you can see. This one was light painted another LED panel used in desert. Pretty old image from 2009. It's a panorama from central Iran. The Milky Way is rising in this image. And now let's go to the definition of night escape photography. As I said at the beginning, it could also include just cityscapes and architectural wonders at night. Often includes the night sky above, interesting landscape. Why? Of course, for the beauty and art of it, but also if you want to communicate astronomy with people, using these images to communicate science with people, as I do. I'm also an educator, a science journalist. So I like my images to be powerful in that field. So an educator can use these images to teach students about constellations. So I need to frame it perfectly for that purpose. But if I just shoot the night sky, it's an isolated part of the outer universe to most people. They cannot communicate with that. If you include a familiar, interesting landmark that they can recognize, something from the culture and country, then they see that the night sky is just part of our nature. It's part of our environment. We have lost that connection due to the light pollution and living in the cities nowadays. Our children have lost that connection. I remember once I took a group of children to a desert, And one of them was looking out of the window as we were coming. It was dark in the summer night. And he said, it's getting cloudy. And I looked too, it was the Milky Way. So he had no idea the Milky Way could be this bright when you're outside of the city and it's visible. Some people coming to my exhibits and often mention that, are these images Photoshopped because the Milky Way couldn't be visible like this from anywhere on the planet? Because they have never tried that in a truly dark sky site. Of course, the colors are not there when we're looking at that, but still you will see plenty of details. And it can express the principles of practical astronomy. And, you know, when you take a picture, when record a celestial phenomena, as I said, it becomes more unique. As part of nature photography, it's based on realistic documentation of nature. That means I do not blend an image of Milky Way from another country with a foreground from somewhere else, unless it's for a purpose of art and clear to the audience. But I do not blend image of the moon from behind me and double expose it to somewhere completely wrong in the northern horizon. And that's very popular nowadays, unfortunately. And I usually give this example: if the night sky is part of nature, it's if you change the position of the moon, capture moon with a telephoto and add it to an image with a wide angle lens where it was not located at all, it's like adding a lion on top of an elephant in wildlife photography. Moon is also an element of nature. There's no difference. But most people don't realize that, because night sky, as I said, we lost the connection to the night sky as essential part of nature. Sometimes the foreground is more related to history and culture, and that's very interesting, because some of these petroglyphs in central Iran back from 10, 15,000 years ago, and some of the starlight that we are receiving, recording on the camera, is also related to 10, 15,000 years ago in the universe, because the light was traveling all the time to reach us. So they're both time machines taking us back to the history of Earth and history of the universe. And the combination is quite interesting. I used a red flashlight connected to the wall of the petroglyph to increase the shadows and reveal these very fine structures. This is a very impressive location in central Iran called Taymare, where about 30,000 of these pictures have recognized so far. And here are the constellations on the right side. These are the winter sky constellations. You can add them using a software such as Stellarium or Starry Night, but you have to overlay it manually. Now let's go through something else about the night sky photography. We try to show the beauty of the night sky often as seen with naked eye, but we have to be clear with people that you cannot see so many stars with your own eyes. It will be less, but there's still, you know, a naked eye observer in a dark sky location, when you are completely dark adopted, you can count more than 2,000 stars in a single time. And overall, more than 5,000. That's very impressive. I didn't try it, but this is the data we have based on the magnitude of the star brightness. But cameras can go more. If you can reveal magnitude 6 of stars in a typical 10, 15-second exposure, that's similar to the naked eye. But if you go beyond that, 8, 9, our eyes cannot see those stars just with unaided, without any optical. So this one is an example with f2 lens at 20-second exposure in Ilha Grande, Brazil. And we definitely see more stars than I could see standing there. But the structure of the Milky Way, as you see here, were completely visible to my eyes, but not the color. The only color of the star was that Antares, the orange star, which was colorful to the eye as well, but less vivid. They connect people to astronomy. They're unique based on location and what is happening in the sky, but they usually lack any serious scientific data. That means we are not here to discover a galaxy or a new comet or nova, but that can happen. It happened in some of my images, especially atmospheric phenomena, which no one was aware of. And I accidentally captured that and revealed it to atmospheric scientists. You can also reveal a nova, an explosion of a star nobody captured before if you were there at the right time. And that happened too. But these are accidents. The night escape photos are not for discovery of the outer universe. For that, we need telephoto lenses or telescopes. Now let's go through some of the techniques and comparison to deep sky photography. If you look at these two images, the previous one was just a very portable, compact setup for night escape photography. But now look at this one with my colleague Amir. He's using a typical telescope mount. When you polar align it, that central area of the mount is going to be polar aligned with Polaris in the northern hemisphere, for example. You have to make it fixed completely for the night, sometimes several nights, because you're satisfied with the polar alignment. You know that it's going to track the stars very well because the Earth is rotating, so you have to move with the telescope. And you go to 2 or 3 objects each night and collect a lot of images to stack them to increase the total exposure and reveal more data in astrophotography. So you are in one place and limited to few targets. And that's, of course, very interesting and fun, but a totally different style to what we do in night escape photography. And the result is also different and very completing. When you put them two together, then the viewers, general public, have a better understanding of what the universe is, because they look at the left side. This is the field of view of human eyes. Orion, that little square next to the Orion belt is where the Orion Nebula is located. And it looks like a fuzzy, unfocused star to the eye. It's visible from even places which are not perfectly dark. Not from inside the city, but from a village or a town, you can see Orion Nebula with the naked eye. And through a telescope, it becomes magnificent, but without much colors. Unless the telescope is pretty big, then your cone cells can see some of the colors of Orion Nebula. But through a long exposure, then you will see the image on the right side and a large telescope. The field of view is the point. The field of view of a telescope is only 1 degree. The field of view of a wide-angle lens could be anywhere from 50 degrees to 120, 180 degrees in a fisheye lens. Another comparison with a solar eclipse, the lower panorama using a 24 millimeter lens and 10 vertical shots. It was handheld during the total eclipses. The foreground, the sky is not that dark. You can do handheld shots as well if you're just taking wide angle shots. And the upper one was my second camera running a 600 millimeter lens, and it was a time lapse. It's not a single exposure. It's a stack of 7 exposures, each about 2 minutes apart. And during that time, the eclipse is beginning, becoming total, and ending. And I put them together to make this composite of the details of the solar eclipse. And if you compare it with the lower part, it gives you kind of complete the spectrum of what is happening during this phenomena. Now let's talk about the numbers. 20-second exposure, ISO 3200 and f2.8. So these are the 3 golden numbers of night escape photography, and they have a range. If you are in a darker area, you need more exposure, you go to 30 seconds, especially if the lens is super wide angle or fisheye. If the lens is not, for example, you're shooting with 24, 28, 35, or 50, then you realize that 30 seconds the stars are trailing, very notably visible, and they're not pinpoint anymore because the Earth is never stopping. The Earth's rotation is turning the sky above us. In order to freeze that, you either have to track the stars with a motor, we call it a star tracker, or you have to limit the exposure which is related to the focal length of the lens. And I will talk about that too. So 10 seconds is for when the lens is not super wide angle, for example, 24, and 30 seconds is when it's fisheye. It's also related to what part of the sky you're looking at, but it's beyond the time we have for this webinar. And then the ISO could be higher if the camera is performing well. For example, it's a pretty cold night, then the camera won't be that noisy. The camera is more noisy if the ambient temperature of the night is high. The sensors become hot, and therefore there would be more random noise on the image and more difficult to get rid of them in post-processing. Then you realize you have to decrease the ISO to get better noise performance and also better dynamic range. But if we decrease the ISO, then we have the problem of increasing the exposure. So what would be the solution? If we can't increase the exposure, if we can't increase the ISO, we have to use a fast lens. And that's where I really enjoy using some of the Sigma art lenses because they're pretty fast and they're very sharp at wide open aperture. So for example, f2, 2.8, f1.4, and similar to that. But the only problem you have here is that first, the lens, of course, needs to be in high quality. So at wide open aperture, you don't see aberrations on the corner, which is very visible or annoying. And second, you don't have a foreground which is too close to you. That's called the hyperfocal distance. If the foreground is too close and you're focusing on infinity, everything in the foreground will be out of focus. So you have to get away from the foreground, or you have to stop down the aperture in order to get them both in focus. And the other thing is single exposure or blending. Sometimes technically it's impossible to get everything on a single exposure. I understand that. But as a matter of realistic documentation of nature, I like to do more single exposure than any composite method. Now let's go to other camera settings. White balance, you can change it, of course, in post-processing because it is captured on RAW. It's very similar in camera or in post-processing. But if you want to review the image as it will look finally, review the image on your screen of the camera, set the white balance near daytime temperature, which is 5500. Sometimes at such temperature, the sky is too yellow because of the light pollution or air glow. Then you reduce that a bit to 5000, 4800, the most typical white balance temperature I personally use. And then all the way down to 4000. But beyond 4000, you realize the natural color of the sky are changing. For example, this image of my friend in silhouette during one of the California workshops, in fact. And focuses on the silhouette. It's with the Sigma 105mm lens. It's only 3 seconds, so he doesn't move that much. In 3 seconds, he could stand still. And because the lens is so fast, there's plenty of stars, of course, out of focus because I'm shooting at 1.4. And it was intentionally in order to show the foreground more. But in this image, the temperature is 5000. So the color of the Milky Way is yellow. If you shoot the same image at 3000 white balance, the Milky Way will be blue. Let me ask you a question. If you do the same with an elephant in wildlife photography, change the color of an elephant completely blue or to red or something unusual, people realize it right away. But Milky Way, which is also an element of nature, if you change the color, nobody asks that. And that's why many photographers are comfortable in changing the Milky Way based on their artistic interest. So that means the Milky Way could be in any color, but physically it's not. Manual focus and focus peaking, which is available in most of the mirrorless cameras nowadays. It's available also in some of the DSLRs later on. Started with Nikon D850, the first DSLR with focus peaking, but others are coming too. And it's helping you a lot in focusing. Usually a good digital magnification on the live view helps you to see the faintest stars in order to focus properly on manual. You cannot autofocus on faint stars with wide-angle lenses. Some of the telephoto lenses with very good autofocus can handle focusing on brighter stars. And then you do the autofocus on the brightest star and then switch back to manual and continue your work. But if you want to be completely sure, go to the live view, then find the brightest star, 5-10 times magnification, go back and forth and find your focus and continue it with the night. You can fix it with a tape or a lens band, which fix the focus for you over the night. And long exposure noise reduction, only use it if the night is too warm and the camera is too noisy. Most of the cameras nowadays do not need that. But sometimes I use it and it's time-taking because this function is going to do the same exposure you did to try to find the noise. If you have done a 20-second exposure, there will be another 20 seconds with the shutter off. That's why you have to wait. And in that 20 seconds, because the shutter was off, the camera is finding the noise in the image and remove them from the first image. It's different from another function called the high ISO noise reduction. This one is a physical identification of that noise. And it's very effective, but time-taking. Do not use it when you're doing a star trails or time-lapse video. Interval and sequence mode, these are for time-lapse, which I hopefully talk about it later on. So what is the maximum exposure you can do without creating trails? On a full frame camera, these are the numbers. 14 millimeter, the most popular lens for night escape photography, gives you 20 seconds. And when you go all the way to 300, it's only 1 second. So 300 divided by f, which is your focal point. If it's a crop sensor, multiply f by the crop factor of your camera. The camera is the APS-C, and it has the crop factor of 1.5. The Nikon cameras, for example, or Canon, usually it's 1.6. Multiply that. Many of the smaller mirrorless cameras are crop factor of 2. So find that, and then you can calculate easily what is your longest exposure with the particular lens you're going to use. You realize on these numbers that when you're shooting with a telephoto lens, the exposure becomes so little that we cannot reveal many stars or deep sky objects. That's why using a telephoto lens, we need another device called Star Tracker. The only two lenses I have tried without a star tracker, and they can still reveal plenty of things in the background, the sky, and the galaxy. My favorites are 135 millimeter Sigma at 1.8, and I always use it almost at night at 1.8. That means wide open aperture, and 105 1.4. So let's go to examples of longer exposure when we do not follow these numbers. Instead of freezing the rotation of the Earth, we want to reveal the rotation in terms of star trails. That's a 45 minutes exposure, and you have two ways of doing that. One way is a single exposure of half an hour or 40 minutes. On a digital camera, the camera becomes very hot in 40 minutes exposure. So try that in cold nights, and try it not very often because it's affecting the sensor if you do it plenty of time in a very hot nights. And the camera becomes more and more noisy. But if it's a cold night and the camera is very good in low ISO long exposure images, for example, I did that many times with Nikon D850 at ISO 64. And in 1 hour, the camera is still not that noisy in a winter night. But this one from 2007 in a World Heritage Site in Iran, these are the tombs of ancient Persian kings from 2,500 years ago. It's a massive cliff, almost 50 meters high, 150 feet. And above it, the brightest star is Polaris. So it's almost at the north celestial pole, where the axis of rotation of the Earth is. And during that time, instead of one shot, I did 45 images, each 1 minute. Why? Because the camera was one of the early phases of DSLRs, and it wasn't possible to do 45 minutes without creating a very ugly, noisy image. So I broke it to a number of images in a time-lapse sequence and stacked them together. Second reason was that it was a bright moon in the sky and a road nearby. If I did 145 minutes, the foreground will be completely overexposed, and the sky as well. All the stars would be vanished. So this trick helped me to keep the foreground light within just 1 minute or 30 seconds, whatever your exposure is. And stack these images. As the stars are moving, you will create the star trail and you don't get overexposed foreground or overexposed sky. That's a method you can also try in some of the most light polluted places on Earth. In the middle of Los Angeles, middle of New York City, you can still do star trail. Maybe you don't get so many stars, but it's still possible to freeze the light pollution using this method. But compare it to natural looking film star trails. These are 2 4-hour exposure on film. One of them right side by my colleague Ocean Zakarian. Would you mind mute yourself? We can hear you, Susan.
Okay.
And 4-hour exposure, if you compare it to the other star trail, the previous image, stars has so many more colors here. And that's the problem with the digital camera and long exposure. The colors are becoming white because the pixels are getting saturated. So if you have one of these old cameras, especially medium format cameras, try it, because it has a lot of use for long exposure images. And I think these films are still available in stores like Samys and any other professional camera store around the world. At ISO 100 is enough, and try it out. You will see, you will be surprised. But you need the darkest sky place. So in digital photography, it is possible to reveal these colors, but they don't look as natural as the other one when you stack them. The reason for doing time-lapse, other than freezing the light pollution, getting many stars, is that you also have another product. It's not only one image, you have a video as well. Plus, you have still shots of 20, 30 seconds, could be of interest. One meteor has passed by and you have captured that brilliantly, while in a low ISO long exposure, that would be very faint and invisible. So there are some advantages, and the disadvantage is that it doesn't look as natural looking as a single shot like this. So let's go on. Another question is, which I frequently receive on social media, is what would be the view to a person standing here? So I try to illustrate it with this result. It's edited differently, and this would be the view you see with unaided eyes standing there. You still see the Milky Way, stunningly beautiful, but without that color. What is the color of the Milky Way? 2 very different edits. When I modified my camera, modification in this case means removing the IR cut filter from the sensor, letting the sensor of the camera to reveal more of the red end of the spectrum where most of the nebulosity in the sky are shining. And by that, your camera becomes astro-modified. You can replace that filter by another one which cuts after that red end. and it still, has all the functions of daytime photography with some limits. So when I modified the camera some 10, 15 years ago, I posted this on social media as a test to see the reaction of people. The right side, it's completely fake color. And it received 10 times more feedback compared to the left one, which is the natural looking color of the Milky Way. So that explains why we have so many exotic, unusual colors of the Milky Way online. But this is not the natural color of the galaxy. So showing you one more example of completely natural looking color of the sky. The Milky Way is yellow. It's becoming more pale as you get away from the galactic center. The green is coming from air glow. It's not aurora. We are in a wrong latitude. Here is La Palma, Canary Islands. It's only 28 degrees. You don't see aurora from there, but it's air glow. And now I'd like to share with you what would be the best season to capture the Milky Way as an arch rising from the east, which is a very popular target for photographers doing a panorama. And it's anytime between February to June. In February, it would be very close to the morning. In June, it's at the beginning of the night. Right now, in July, you don't see the arc anymore close to the horizon. You can still get it higher up. It has passed. But now it's a Milky Way season because you will see it most of the night. Until early morning, you will see the Milky Way going across the horizon. And this is the view we get anytime in September and October. At the beginning of the night, the Milky Way is like a column over the west. And it's another iconic view of the galaxy. This shot was from Yellowstone National Park, and this one as well. So in July, August, you can wait until midnight and you get the same view. In September, October, it would be at the beginning of the night. I have put together some information for you which could be helpful. Venus is against the Milky Way in most of the summer this year. As we get to August and September, Venus is higher and you can see this beauty and the galaxy. The image on the right side is showing Mars at its brightest and the galaxy. But now we have Venus for this combination. Venus-Mars-Moon conjunction just passed, and some of you may have noticed that. And Saturn is in opposition, that means closest to the Earth, brightest in the sky, August 2nd, and Jupiter also August 19th. So these two bright planets are visible the entire night through August and right now as well. And you can see them tonight as well. Jupiter is much brighter. So now let's go to some lenses, because that's the more important part of nightscape photography. This is my colleague Oshin, which I talked about earlier. He's using analog cameras and digital at the same time. And this is during one of our workshops in California. I can't remember which lake it is, but it's one of the high Sierra lakes. So 14 millimeter, as shown in this picture, is perhaps the most popular wide-angle lens for nightscape photographers. Look for 2.8 or faster. Use a prime lens if you can instead of zoom. If you're using a zoom, use a short range zoom, such as 1424 or 15 to 30 and similar, instead of very long range, such as 28 to 200 or these typical daytime lenses. These are not useful at nighttime because of so many layers of optics that reduce the amount of light you can collect, and they're not usually fast enough. And then we get to full frame. If you have a full frame camera, these are the two most popular lenses I suggest. You can also use any of these on crop sensor. You just lose the field of view, but they are useful on those cameras as well. 1424 2.8 is perhaps the most popular lens for time-lapse photography worldwide. Once it was only produced by Nikon, now it's available by Sigma as well with the same sharpness. It's very popular. 28, 1.4, and this new lens 35 1.2 is very surprising. I tested this Art Sigma lens at 1.2 and it was still superbly sharp. So I think it's a very good lens, especially for videos of the night sky. If you have one of those cameras which can perform very high ISO, such as Sony A7S or Nikon Z6, Sigma FPL, or Canon R6, these are more cameras made more for low light photography, especially Sony A7S, and couple it with 35 1.2, you can reveal the Milky Way in real-time video easily, or reveal anything of the Aurora Borealis, even faint Aurora in video in real time at very high ISO, of course, ISO of 12,800 and higher. Now let's go forward. But do you need all of these lenses? I will mention what would be my best combination. These are some of the lenses I have tested, and I know they're very popular in low light photography. Fisheye is more technical. I recommend it for a person with a bit more experience, but it gives you plenty of creativity. For example, during a meteor shower, during a massive aurora storm across the sky, or something astronomical, atmospheric phenomena all over the sky, such as a halo around the moon. So, or creating 360 virtual reality shots. For crop sensor equivalents, these are some of the options. This lens, 1835 1.8 by Sigma, is pretty sharp. And favorite combinations, I don't know what is the source of these lines coming on my screen. It's coming from Peter's cell phone. Favorite combination is 1424 and 70 to 200 millimeter. These are, perhaps with these two lenses, you can do anything you want at day and nighttime. It covers almost anything. If you want to add, you can add a prime lens. Or another combination is 2 prime lenses and 1 telephoto for close-ups of moonrise, sunset, or even deep sky photography or daytime wildlife photography. So let me stop the share 1 second and come back to you to see if those lines can be. Yeah. Okay. Yeah, this is an example of 35 millimeter 1.2. Here we have a look at 3 different lenses: Milky Way with a wide angle lens, now with 85. Now the same part of the sky with 105. This is with the star tracker, and it was very surprising to me when I captured this in Sierra Nevada, California a few years ago. It was with a modified camera, so this camera can reveal more of the nebulosity compared to regular cameras. It's Nikon D810A. 2 manufacturers made astronomical cameras based on their regular cameras. One was Nikon with D810A, and the other one is Canon. The latest version is RA. So the EOS R has an astronomical version called RA, and it gives you the option of revealing all these nebulosity. Try one of these or modify your camera. There are companies doing that if you're really thinking about deep sky photography and not night escape. For night escape photography, you don't need a modified camera. But for deep sky at 85 millimeter and higher to reveal these nebulosity, it's definitely essential. And in this exposure of 15 seconds, I was surprised to see so many nebulosity in a single exposure image. This was like a dream 10 years ago, but now it's easily doable with a fast lens like Sigma 105 1.4, which was, I think, which was the lens I used for this image. Or this one is with 200 at 2.8, the Orion belt, and then comes the Orion Nebula, another single exposure shot. because of the tracker I have used, the foreground is not very sharp. If you look very closely to the screen, you see that it's trailing, it's moving, because the tracker is following the stars, and therefore the foreground becomes diffuse. But since it's in a silhouette, it doesn't matter because it's dark anyhow, to a certain limit, of course. Yeah, this needs its own webinar, of course. Usually in my workshops, in-person workshop, I talk about this for one full day. So I referred you to this tutorial video on YouTube I have on how to use a star tracker, or more tips on my general webinars, and try it out. This is one of the star trackers, which is very popular, called Polari by Vixen. And these are some examples with the star trackers. With Sigma 105, this is about 5 minutes with a single exposure of 5 minutes with a modified camera. These nebulosities are in constellation Cygnus. And I have used a filter called the Sky Glow, which cuts the extra light from the sky in order to increase the contrast of nebula. This is from just a single 8-second shot from a time-lapse sequence, and I was lucky to capture this meteor and a couple of nebulosities in the sky. This is a 2-minute shot with a recent comet last year in July. It was a beautiful comet in the sky. We hope to get another one in December, by the way. It's called Comet Leonard, and hopefully it becomes as bright as this one. And this is the lens, one of the lenses I tried for deep sky photography. You have many options. You can use a fixed 135. It's a very good entry lens for deep sky photography, I would say. Sigma Art 135 at 1.8. It doesn't reveal galaxies and structures, but plenty of nebulosity and star clusters. Close-up details of the Milky Way, good for panoramas. But if you want to go further, this is 150 to 600. And you see the star tracker needs to be larger. The Polari cannot handle that. So you need a bigger star tracker because of the weight. Or the 60 to 600, that's another option. Or the prime lenses such as 500, f4, and similar. Result after many exposures, they're stacked in order to increase the exposure of around nebulosity around Antares in the Scorpion. And these are with 600, the Sigma 150 to 600 at maximum focal length. And it's surprising to show that these galaxies are recordable. There are structures of spiral arms visible in another galaxy with just a telephoto lens. Yes, that is doable, even with the smaller lenses. Even with 200 or 400, you can reveal some of these structures when the galaxies are not too far in the outer universe. These are neighboring galaxies. Or this nebulosity, it's a planetary nebula, the ending phase of a sun-like star when it's dead. And speaking of the moon, with the telephoto, anything in the range of 600 to 1200, using a 2x extender, you get very close views of the moonrise. This was with 600 from Boston Light. And I like to mention also that, you know, this term as a supermoon is not really helping, because people think that the supermoon is like 10 times larger than a normal moon. So the supermoon, on average, is just less than 10% larger than a normal moon. So that means most of the people never realize a supermoon is bigger or brighter. Only experienced observers realize that it's a bit brighter or a bit bigger than a normal moon. The reason we see supermoon, and we agree with that, because when the moon is on the horizon, our eyes, our brain perception is that the moon is larger. And that's called the moon illusion. It's a very nice phenomenon. In fact, without that, the moon wouldn't be this beautiful, but it's part of the optical illusion we have. In order to plan with the moonrise or any other celestial objects, especially in a telephoto, use one of these popular apps, PhotoPills, Planet, or TP. TP was the original app made for this purpose. Then came PhotoPills, and then came Planet. All of them has similar functions, and they're very user-friendly. If you want to measure what would be the size of the moon on your image, this is a very simple formula. Of course, the size of it's designed for film, so the size of the film is 36 millimeter here on a full frame. So then you can imagine what would be the comparison size of the moon to a 36 millimeter wide frame of film. And let me give you this information as well. On November 19, we have a lunar eclipse. It is visible in the US. In almost all of the US, it is visible. And it's, in fact, one of the best places in the world to see it. You can see it also partially from Southern America, and you see the whole rest of the map. This is a good a total lunar eclipse we have ahead of us. So you can plan for it either with wide angle lens such as this, or a close-up shots, which I have shown you before. We have a total solar eclipse coming as well. It's not visible from anywhere in your backyard. It's going to be in Antarctica. I'm leading one of the tours with Quark Expedition, going to Antarctica to see that. But the next one in the US is quite interesting in April 2024, and it's crossing most of the country. So very much look forward to that. It's about 4 minutes of totality. It's going to be a big hit for photographers and astronomy enthusiasts. So I think we're running out of time, and there are questions too. Let me stop the share and check that with Mike. So Mike, how are we doing with the time?
Well, we're doing great with it. We've gone a little bit over, but this has been an amazing presentation.
So
I do have a couple
I would
questions for
say,
you, and
yeah,
some.
I would just show 5, 6 more slides in order to finish it up, and then we go with the questions. Now, what would be the maximum time we have?
We're
So,
free
I
to
can stay on as long as you guys want. So as long as you want, Babak, please.
okay, so we continue another 15 minutes to have total of 1.5 hours, but 5 minutes of last few slides.
Sounds great. Thank you.
Sure. So, yeah, part of my book, a chapter of the book is about light pollution. This is a collective work of my colleagues, the Word at Night team. And 2 chapters at the end discuss and show the images of beauty of the night sky, but also the problem of light pollution. And I'd like to highlight a part of that. This is the Eastern US, and you find plenty of information on this page I made on my website where to find these maps, because these maps are very useful for nightscape photographers. You can overlay them on Google Earth map, and based on that, plan on going to dark sky areas. Or you can use the darksky.org website. It has a dark sky finder option, and it gives you the list of all the places which are already designated as international dark sky parks, including many of the national parks. But look at here, all of these red, orange, purple, these are light pollution. New York City, then DC, Philadelphia, Boston, it's just filled with light. So in order to escape that, you have to go to the blue and black areas, not to the ocean, of course, but finding these little spots in the woods where it's dark enough to capture the Milky Way. There are more of them, of course, in the western side of the US, where it's more friendly to astrophotographers in a way. But look at this big city, Dubai, and it's almost empty of stars. That's the story of most of planet's cities and urban areas. That's why about 2/3 of human population can no longer see the Milky Way from their residential area. It's not only cities, also towns. Many places are small, but they have too much light that we don't use at night. Some of these towers are empty, but they're advertising themselves with bright lights, and they keep shining the whole night. And it's not only an astronomer's issue, it's creating major environmental problems for birds, migrating birds passing by, and for human body as well. In the past decade, we realized definitely light pollution is affecting human body by changing our circadian rhythm, by changing our sleep cycle, and especially the new white blue LEDs. So if you have some of these LEDs at home, anywhere near your bedroom, think about changing that to warmer LEDs of the Kelvin temperature of 3000 or less, preferably for bedroom at 2200 and bathroom similar 2700. But anything above 3000, it has too much blue light in it that will change that sleep cycle. And that, of course, we cannot do that. We cannot change it with the city lights. And already some of the cities have changed to white blue LEDs across the board. Hopefully in the US, the American Medical Association officially announced in 2016 that these LEDs are harmful to human body, and cities are following, most cities are following the regulation. But in the cities, we are disconnected from the night sky. However, many people can still see some elements of the night, like this moon setting over the Arch of Triumph in Paris and Champs-Élysées Street. Or compare these two images. One is from the Sea of Tehran with population of 15 million. So the field of view of these two images are very similar. Orientation is also similar. That means that Milky Way should be visible in that image. It's almost completely gone with a separation of only 70 kilometers, in fact, the two images. Have a look at this article online. Just Google Nat Geo light pollution. We did this a couple of years ago and has plenty of information about light pollution, sources like Las Vegas and how much light we're wasting towards the space and creating issues for environment, and how easily we can change this. In fact, it's not like plastic in the ocean that takes decades to clean. This is a matter of only a few years if we educate people. So I think photographers have the power to share this story. As I said, the four elements of image, one of them is the story. And your story could be, at least for some of the images, the importance of dark skies for all species, especially nocturnal species, for insects. We have decline of insects in the past 5-6 decades, and many of them are nocturnal. Part of it, big part of it is, of course, climate change, but another major component is light pollution. And we realize now that this is a big issue. This is Luxor Hotel in Las Vegas, and it's sending this massive blue light to the sky in the past 20 years or so every night. And when you go there, there are many bats and birds flying around the light. It's an evidence of how much we can change the environment by just sending lights, by using lights which are not necessary, in fact. So thank you, everyone. And these are some of my contacts you will find out. And I think at the last slide I have some of the resources that would be useful to you. These are websites. My project, The World at Night, we're a group of 40 photographers, have plenty of examples that can educate you on how these images look like. Spaceweather.com with the latest phenomena. Heavens Above is for satellites passing up in the sky. Sky Telescope is the most reliable astronomy source online for educating yourself about the stargazing. And some of the articles I did is on this website as well. So let's go back to the room and take care of your questions.
Thanks.
First off, thank you so much. You've gotten so many amazing comments. Wonderful. Everyone seems to have really, really enjoyed this event. So
Really?
thank you. Mike, do you want to kind of go through the chat?
Yeah, and a lot of them you answered as you went along. So I'll just throw a couple highlight ones at you. One of something a little less technical was, you have a favorite place to shoot night sky, and is it somewhere you've been or somewhere you want to go maybe?
Yeah, Nepal. I like to go back to Nepal for sure, to Himalayas. The sky at high altitude is pretty impressive, crystal clear.
Beautiful.
The only problem is that you get altitude sickness.
Another one, you mentioned the app that had the overlay of stars. Was it called Stellarium?
Yes.
Okay,
It's a free app. Another one is a Starry Night.
Star what?
Starry Night.
Starry Night. And
I saw one that I was actually curious about was whether they're single photos on most of these or composites.
Most of my photos are single exposure.
someone mentioned that they do a lot of night sky photography with their Sony A7, and when they zoom in post-production, that they see these little red specks on in the stars, and they were wondering how can they avoid that and why is that?
So the hot pixels are coming from, the noise in general coming from different sources. One is the random noise because of the temperature of the sensor, the readout noise, and that increases when the camera is older or the camera is less suitable for low light photography. For example, very high resolution cameras such as A7R or even the Sigma FPL. It's a very high resolution camera. Physically, they're not made for low light photography. However, the manufacturers are changing the processor in a way to compensate for that. Because when you increase the resolution of the camera in the fixed size of sensor, each individual pixels would be smaller. As the pixels are smaller, they collect less light before they get saturated. So it's a physical thing related to a term called quantum efficiency. That means what percentage of the light coming the sensor is able to record. Our eyes has quantum efficiency of less than 10%. Compared to a camera like Sigma FP has quantum efficiency of 50%, average for most of the cameras. Some are lower, some like Sony A7S higher, near 60%. The astronomical CCDs we connect to telescopes, some of them are up to 90%. The CCDs used for military, some of them are 99%. But the pixels, as they're smaller in your sensor, you lose the quantum efficiency. So first, think about a camera with lower megapixel. That gives you more low light photography abilities. Second, try to remove those noise in a raw processor software. When you open them in Lightroom or in Adobe Camera Raw, which is a plugin coming from Photoshop, they recognize these hot pixels. After a second or two, they're gone automatically from BIOS of the file. If you can't remove them and you see they keep coming, you have to make a dark frame. That means taking a picture with the cap on, or use the long exposure noise reduction option on the camera, and the camera will find it itself. If the camera is not able, the last option is taking a dark frame, and you can subtract that dark frame from the original image. But try shooting in colder nights, and the camera will be less noisy. The easiest way of handling noise.
We got a lot of that thing. That was an amazing answer. We got a lot of questions on two common ones were just when you're going out. One was, what's an easy way to get good focus for night sky? And even on say a night that is cloudy was one of the questions. And what are your general settings for a beginner that they can just kind of refer to in an instant?
For focusing, use any point of light on the horizon. When you're shooting with a wide angle lens, for example, 14 or 20, anything beyond 30 feet is infinity to the camera. So that means it doesn't matter if this is a star or a city nearby or light on the horizon 200 yards away, that's infinity. So just focus on that. If you're using a telephoto lens, it's another story. Then find a source which is really far away. But with wide angle for night escape, if it's cloudy, you don't have any star in the sky, use a light on the horizon. And for setting the golden numbers, I repeat, try with 20 seconds, ISO 3200, f2.8, and change them one or two stop. upper or lower and see how it goes. Usually on a high megapixel camera, 20 seconds is too long. You see the trails too much, but a little bit of trails doesn't bother really. Yeah, it's okay. You only see them when you zoom into the image. But if you want to really pinpoint the stars, it's usually around 10 seconds for a wide angle lens.
Oh, thank you. There. Another question was, and it's being asked again, are you using a astro converted camera, and how do you get good color? And then related to that, do you prefer H alpha versus full spectrum for
Yes, I recommend full spectrum modification of the camera. That means removing the IR filter completely and do not replacing it with anything else. That's very good for IR photographers, but not for astrophotographers, because you get a lot of light also from the infrared part, including from air glow. The sky becomes too bright. Okay, so it's better to cut the IR for astrophotography for this purpose. If it's about planets and telescopic photography, it's another story. But for this purpose, the H alpha modification, the usual astro modification, is the best. And in order to get the right color, if the camera is made by a manufacturer such as Canon RA or Nikon D810A, this is not in manufacturing anymore, it's old, but you get the right color from the normal daytime temperature. It's already adjusted in the camera. If you have modified your own camera, then take a custom white balance from a white paper or the background sky, something which is not cloud, not Milky Way, just dark sky, and insert it to the camera as the custom white balance image. You will find it in the menu.
Okay. I'm sure, and can you say where we can follow you again? I know a lot of people, I know you showed that, but at least with Instagram.
Yes, just my name, Babak Tafreshi. I'm more active on Instagram than other platforms. That's where I have a larger audience. And also through some of the newsletters I send. If anyone has been on my workshops or webinars before, they receive a newsletter every now and then. But most of the events and things I do are posted on Instagram.
Beautiful. And everybody's saying thank you so much. And I know I want to say thank you from Sigma, and I'm going to pass it on over to Rui, but this was really an amazing presentation. So thank you for that.
Thank you so much. Thanks everyone for hanging in, and Babak, thank you so much for your time. This has been really inspirational, beautiful.
Thank you.
Hope to see you again soon. Maybe we can get together for a hands-on workshop.
Look forward to it. All the best.
Good night. Take care. Bye-bye, everybody.
Thank you.